All right, we're going to take a look at these practice problems. And again, when I come to a titration curve, I try to think, or titration problem, I try to think of like, what am I looking at? What's in my Erlenmeyer? What's in my Burette? So it's telling me I have this amount of KOH in my Erlenmeyer flask, and in the Burette is HCl. So I'm starting with nothing but a base, and I'm going to keep titrating it until it's an excess acid. So I know it's going to look like a curve like this, where I have my initial pH. I said I'm going to have probably something that's halfway between there. I'm going to have my equivalence point, and then I'm going to have an excess amount of acid. All right, those are my 4 points that they always ask you to do, and as I'm doing this, that's what's going to be in my mind. So we're going to start off at the initial one. This is saying that I add 0 milliliters of this amount of acid, and they can do that because they're trying to keep the same voice as to how much acid was added by the burette. But this often confuses students because they think that's what's in their Erlenmeyer flask in a way, because this is just like flashing at you. But this is why I like to draw this to keep myself on task. So I know it's all going to be a strong base. So it's really the KOH that is in this Erlenmeyer flask. I write that formula just like it was a strong base. Well, it is a strong base. And we know that when it's strong, it 100% ionizes and it becomes all ions on this side. So right away, I can see how much hydroxide concentration is. I have to keep track of the fact that that's the information I'm given. I'm not given hydrogen ion concentration from this. I have a hydroxide, which always means I have to calculate the POH to go on to do the pH. So this makes sense that my initial pH is going to be basic because it's nothing but the KOH. Now, let's add this amount of acid into this Erlenmeyer flask. A lot of times they don't add repetitive information, which is what was in your Erlenmeyer flask. And I had 75 milliliters of 0.5 molarity of KOH. I like to delineate these separately because immediately I know I need to get millimoles. And I like to keep track of how many millimoles do I have, which do I have more of, so I know if I'm going to have a basic or an acidic pH. I can clearly see when I take the volume times the molarity, I have way more base than I do acid, so I'm still going to have a basic pH. So that means I'm still have a lot of hydroxide in there. So because it's a neutralization reaction taking place, this base is going to be neutralized by that amount of acid that was added by the burette. I need to take the total volume that is now both what I started in the Erlenmeyer and what was added. And remember, each of these are separate problems. It's like the previous one didn't even exist. So when I take this, I find out that my molarity is 2.272 molar. Again, I'm going to have to find my POH, and then I can go on to find my pH. So it's gotten a little more acidic, even though it's extremely basic still. So here I am over here. All right, now, separate problem, I'm going to add 165 milliliters. What they didn't write in here was I'm going to add it to 75 milliliters of 0.500 molar of KOH. So just be prepared. You might have to add that piece of information in. Get them into millimoles. So I see that I have 41.25 millimoles. I have the same amount of acid. So remember, when you see that these concentrations, and they are in millimoles, that the amount of base is equal to the amount of acid. So I'm at the equivalence point. That's the definition of an equivalence point. This is a strong base, strong acid titration. It doesn't matter, but at the equivalence point, it's going to be a pH 7. It's complete neutralization. Let's go on to this part. So we've done the initial, we've done it halfway, we just did the equivalence. I know I'm landing somewhere in the excess acid. So here's how much is coming from the burette. I pretend it's another individual problem of starting with this amount in the Erlenmeyer, which I know always gives me 41.25 millimoles, and if that was consistent always, because that's what was in your Erlenmeyer. Didn't need that for the first one. And so how many millimoles do I have of the strong acid? I have 50 millimoles. So now I can see that the amount of acid in millimoles is greater than the amount of base. So now, because I have that information, I have really an excess amount of acid. So I'm going to take how much acid I have, and I'm going to minus it from the base because it's going to neutralize it, and divide it by the total volume. So I have 275 milliliters, and this becomes 1.4, well, it doesn't become that. That's its pH. So let me just see what I get here. So I have 50 minus 41.25 divided by 275, and I get 0.032 molarity. And that is the one that's going to give us a pH of 1.49. So it makes sense that I am now in the excess amount of acid, and that's what I'm going to get. So that is your first one. It doesn't matter you started with a base, the same thought process went all the way down. The second problem that we're going to look at is this one, and it's looking at, again, what is in your Erlenmeyer. It's going to be HCl. What's in here is NaOH. The important part is they're both strong. So that's what I have to keep track of, is I am now in a strong acid, strong base curve. So I know it's going to look like this. I have that in my head as I'm doing these. So I have the initial one. It can tell me it added nothing of that, but I'm adding it to this amount of HCl. And I did write this, that this is how many millimoles we're starting with, just to help with writing all this information down as I lecture. But I really don't need the fact that it was in that many millimoles, because if you're a strong acid, you have the molarity of this acid, which 100% ionizes into these ions. So now that I have that the hydrogen ion concentration is equal to 0.15 molar, I can find the pH from that, and it is 0.823. So very acidic for the initial pH. Where I'm starting is very acidic. All right, now we're going to add some base to it. We're going to add 10 milliliters of this. We're going to get it into millimoles. As I see this, I can see that my millimoles of my acid are greater than my millimoles of the base. So I should have an acidic pH. I know then that I have an excess amount of hydrogen ions still, because I have more acid than I do of base, and this is going to neutralize each other, divided by the total volume, which is 85 milliliters, and I get 0.0735 molar. I can find the pH from that information. It's 1.13. Now I'm going to go on, and I think, all right, we did my first one, second one, my third one should be an equivalence point, just the way that this is done for these problems for titration. And I do. I have equal amounts of the base and the acid. So because it's a strong acid and a strong base, I know that the pH is 7 at equivalence point. There's no calculations that need to be done other than to prove that they have the same number of millimoles. All right, now I'm going to go into the excess base, is where I'm thinking I'm heading. Get that into millimoles, and yes, I have way more base than I do of the acid, so I should have a basic pH. So now this is an excess of hydroxide ions, and I get 20 millimoles minus the 11.25 that comes from the acids, divided by the total volume, 40 plus 75 is 115, and I get a hydroxide ion concentration of 0.0761 molar. So my pOH is 1.12. Using those equations, I can find that my final pH is 12.88, which is that excess basis I was talking about.